편히 섰던 것도 잘못인가요? 나 차가운 도시의 따뜻한 여잔데 그냥 좋아한단 말도 안 되는가요? 솔직하게 난 말하고 싶어요. 사라져 아니 사라지지 마. 내 맘을 보여줘 아니 보여주지 마. 하루 종일 머릿속에 네 미소만. 우리 그냥 한번 만나볼래요. 나 오늘부터 너랑 감을 한번 잡을 거야. 너 매일매일 내게 전화도 할 거야. 밀가루 못 먹는 나를 달래서라도 너랑 맛있는 걸 먹으러 다닐 거야. 너무 sweet한 날 정말 달콤한 걸. 너무 sweet한 날 그냥 좋아한단 말도 안 되는가요? 솔직하게 난 말하고 싶어요. 사라져 아니 사라지지 마. 내 맘을 보여줘 아니 보여주지 마. 하루 종일 머릿속에 네 미소만. 우리 그냥 한번 만나볼래요. 나 오늘부터 너랑 감을 한번 잡을 거야. 너 매일매일 내게 전화도 할 거야. 밀가루 못 먹는 나를 달래서라도 너랑 맛있는 걸 먹으러 다닐 거야. 사랑은 이렇게 생기는 게 아니겠어. 어쩌면 내 맘의 반쪽을 내게 걸어보는 건데 나는 오늘도 내게 잘 것만 같아서 난 한 번 더 너에게 다시 달려가 볼 거야. 나 오늘부터 너랑 감을 한번 잡을 거야. 너 매일매일 내게 전화도 할 거야. 매운 거 못 먹는 나를 달래서라도 너랑 맛있는 걸 먹으러 다닐 거야. 나도 그대처럼 좋아요 좀 알려줘. 나도 너랑 말 좀 할 수 있게 해줘. 나는 불이 죽어서 오늘도 포기하고 뒤를 돌아볼 때쯤 날 붙잡는 넌 너무 sweet한 날 정말 달콤한 걸. 너무 sweet한 날 끝까지 너 다가가면 나 정신 못 차려. 안에 꽃은 모두 그냥 좀 바람이 불게 놔줘. 왜 그럴까 사람들 그냥 볼 기분이 좋아. 눈치 없이 밖을 나가 볼까. 왜 이럴까 너가 살고 바람이 좋아. 내 맘만 노래 걷어 늘 사실 너와 그릴 수 있는 얼마나 좋아 좋아. 더 깊은 널 기도하면서 내 곁을 맴돌고 있는 보다 필요 없어. 내 곁에 있고 싶어. 앞서서 이 시간 잘 살아 사랑하라. 그 사람들 그냥 본 기분이 좋아. 눈치 없이 밖을 나가 볼까. 왜 이럴까 뭐가 설렜다고 본 바람이 좋아. 내 맘만 노래 걷어 사실 너가 그릴 수 수 있는 날만이 좋을 더 나를 기다리면서 내 곁에 맴돌고 있는 난 보다 필요 없어 내 곁에 있고 싶어 나 이 지나갈 때까지 한 사람 더 사줘요 단지 봄이 오는지 일곱 번 내 곁에 서서 알아주고 싶은 알고 싶어 보다 필요 없어 내게 살고 싶어 난 붙어서 이 지나갈 때까지 한 사람 한 사람 in this actually point from this tab. So we have to go for the story like you did it like this, and every section in the story frame section can utilize to add or delete the frame grid like in the tabs. So today the application of the mass source in this node option. Actually in Perform 3D there are two phases of working. The first one is the modeling phase and another one is the analysis phase. Most of the works, most of the modeling part, assigning the loads, etc. are done in the modeling phase. And the application of load cases, analysis structure are done in this phase. Also, the extraction of the results are done in this phase. So here, at the first or starting point, we have to start from the node points. So the nodes has already been assigned and the geometry of the structure has been defined in the box for, if we select for node 12, this one is the fixed support. For example, if we have to assign the in support, then we have to go for this as like in detail. So this one is the in support. And also if we have to assign the roller support, we have to go for this one, vertical displacement. And if we select some nodes, now I select this node. Yes, this one is the roller. And this is the insert boundary. By translation, we have to go for assigning the mass. First of all, let me introduce the name of the mass source. Let me say get load 0.25 like load. Okay. Then we have to specify the weight or masses and optional tributary area like H1 translation or 2 degree of freedom for translation and 2 degree of freedom for rotation. So it is 6 degree of freedom at the node. This can be applied in different ways. The first way, the simple way is to import the structure from ETABS and the mass source can be assigned to each node of this structure. And another way is to insert the coordinates and we have to calculate the system point of the structure or lump mass. You can say it's lump mass at the story level. We have to assign the coordinate and we have to input the coordinate here at each story level and input that mass system, lump mass. And another way is to import the coordinate as well as the lump mass system as a CSV comma separated file or text file, which can be generated in the tabs. So I'll try this one. So let me check in the tabs. If we run the structure, first of all, we have to analyze the structure, analyze the structure to generate the story mass by diaphragm and export that masses into Excel CSV file or text file and import that files into the Perform 3D, which is compatible in Perform 3D. So here if we see the display table and we have to go for other definition for mass data, then click mass summary by diaphragm. Let me check. Yes, these are the masses summary by diaphragm. So let me export this mass to Excel sheet and I will convert this into CSV file. So the Excel sheet is generated here. Here these are the story diaphragm, story 3 to 1, mass in x direction, mass in y direction, moment of inertia, and center of mass in x direction as well as the center of mass coordinate in y direction. So we have to convert this file. We have to convert this file into the compatible file for Perform 3D. So if we look into the Perform 3D, here is another tab which is import and export. Here we have to import from this import structure data. Now first of all we have to import the node only. So for the node to be imported, this line must have H1, H2 and D coordinates of the node and may also have the load or mass. Node must be set before load or mass have been imported. So first of all, we have to import the nodes for the diaphragm masses, and after that, we have to import the masses or load. So let me make that Excel file compatible to this side, to the perform readable file. So here, first of all, we have to assign the coordinates. So I will make another sheet here. These are the XY coordinates, and it means go for Z coordinate. Z coordinate. It is called H1 direction coordinates, S2, or simply we say H1 translation, S2, H1, S2, and Z. For Z coordinate, we take the coordinates of the structure. It means 3 meter, 6 meter, 9 meter. So for exploratory, cos is exploratory becomes 9 meter. This one is 6 meter, and this one is 3 meters. 3 meters. So these are the expected coordinates. After that, we have to go for H1 translation, another one is to translation, third one is B translation, another fourth one H1 rotation, S2 rotation, and finally B vertical rotation. So here we have to copy the masses in X way for this one, and this one is 0. There is no any value for translation. So similarly, H1 rotation is also 0, and S2 rotation is also 0. And the value given in the graphs is moment of inertia, which is called V rotation. This value is rotation along the Z direction. Okay. So let me shape this V rotation. This value is rotation. Z direction. Okay. So let me save this. I have to save a command related variable to next, then put somewhere in my system. So yes, this one. And at the time of copy the file, after extracting the importing the file into detail, sorry, for PD, you have to skip first two lines. Okay. So let me import. Yes. Command related value to this. Somewhere in yes, right, this one. And at the time of copy the files, after extracting the importing the file into GitHub, sorry, for 3D, you have to skip first two lines. Okay. So let me import this coordinate CSV file here. Then from import option, here go to nodes only. And I browse the location, so coordinate which I recently saved, and we have to skip first two lines. I already mentioned that in CSV file. Then this file contains load or message. Yes. Let me test. Okay. The operation is complete and number of nodes read by this Perform 3D are three. It means three coordinates for each story. It means story first, story second, and story third are already read here. So I'll check OK and I will press OK. So these are the coordinates for the diaphragm message entries. So again, let me check for message and I have to browse. The already came here. I have to skip two lines and let me paste. Okay, the messages which have been assigned, which have been copied in CSV file has been built by this software with the help of importing the comma separated file. So let me check. Okay, so after doing this, we have to update the story label because the story at the story level, the coordinates for lumped mass has been assigned. So we have to assign this coordinate in each story. So if I go to frame here, let me go to story one, and let me check this. So let me convert this 3D into this elevation, either F1 or S2. Then for the story one, other nodes has already been selected, assigned, and the remaining node is the last node we had just assigned for lumped mass system. So this is updated. And similarly for story two, there is also only one value. And similarly for story two, there is also one value. So this is the point where in the tabs we saw the diagram like this. Yeah, like this we assign for these coordinates. So after this, we have to go for constraint. In ETABS or other FEM software, these are the diagram either assigned either by the help of joint or with the help of cell. cell diaphragm or with the help of joint diaphragm. So in perform theory, we have to first table because the story at the story level, the coordinate for lump mass has been assigned. So we have to assign this coordinate in each story. So I could assign a one type of for these coordinates. So after this, we have to go for constraint. In ETABS or other ACM software, these are the diaphragm either assigned either by the help of joint or with the help of cell diaphragm or the help of joint diaphragm. So in perform theory, we have to first define, let me say that one is gentle rigid for this one, we have to choose first option in our case. And if we go for squaring one, okay, so let me select this and assign the diagram. Squaring one, yes. Again, if we define another one for squaring two, let me set it to, let go for squaring two, this one, and finally T3 for squaring three, select this course, three, select this course, and check that. So the complete works for node element support, mass, and constraints has been done in this model. And the next video, we'll continue from here. It means we will assign the properties of the elements and go and finally run the structure to obtain the model property of the structure. So we have process. So we have following in every process. Keep watching my videos. Be safe and stay healthy. Thank you. Bye. Welcome to my YouTube channel. So today in this video, properties of the structural element that we define and simply apply by taking the compound of each element like beam, columns, or slab. And in the previous video, the orientation of the elements has been done, as well as the addition of elements, support system, constraint or diaphragm, and an application of seismic mass or seismic weight of the structure has already been defined. So today, let me go to the component properties. Here, there are 6 properties in component A. The first one is the material. You can see all type of material we have to use in the structure for mounting purpose. For example, here is it's a inelastic 1D concrete material, one-dimensional concrete material in its concrete. The first one is the inelastic steel material number 2D. We call it or we assume it as Fe500 or Fe400 or Fe550 for the structure. Then these are the elastic steel material for tension only, for buffering, then elastic shear material for the wall, diagonal compression material for the wall, and these are the elastic material for fiber systems. So here in linear analysis, these things are not needed, but while doing the nonlinear analysis, performance prediction, dimension analysis importantly, respective to material definition and the mandatory. So without the definition of the material, for example, if we take the reference concrete, the confined and unconfined concrete and rebar material, for any further works cannot be continue without the material definition. So here, another one is the elastic there. In elastic, there are also different parameters. So with parameters, we need to assign in our structure that should be defined in this step. So for example, if we have to assign the moment hinge rotation type for the line element or beam element, we can select this one. And this trilinear backbone relationship, positive function relationship, in the moment hinge, simply the bending moment versus bending moment in y direction and deformation in x direction. These parameters have to be applied here in different cluster. So here, this model is only for linear purpose. We shall discuss more detail about these nonlinear things while doing nonlinear analysis. So for now, let me go to the process part or the material. First of all, we have to assign that. So let me use elastic material for the slab or shell. And so here we have to assign the stiffness parameter. So here, if we take the M20 concrete, then the M modulus of elasticity is 22361, which comes with the formula 5000 root FCD. Then Poisson ratio for concrete is 0.2. So let me check and save. After that, let me go to cross sections. Here there are different cross sections for beam, column, shear wall, and slab. So let me choose first the beam cross section. Go to move, to 250. Okay. Then our beam is rectangular in shape. The width of the beam is 30 mm and depth of the beam is 50 mm. Then if we calculate, if we press the calculate button on the parameter has been calculated here, and we the axial area, torsional inertia, shear area, and bending inertia. So for the material stiffness, we already said that modulus is 22361 for M20 concrete. Poisson ratio for the concrete is 0.2. And this shear modulus calculated by the formula which we have already studied in strength of area. So let me check and let me check the shear modulus is calculated there with the formula in the relation of Young modulus and shear modulus within the shear. So here we cannot go for inelastic strength at this tab now. So the section of the beam is defined, that is the column section status is defined. Into 350. Okay. Then similar like beams, 350, 350, calculate 2361 for M20 concrete for concrete Poisson ratio, and let me take. Then another one is the slab. So we define new slab 125. Okay. Then this material is the slab we have defined in material tab. The thickness of the slab is 125 mm. For membrane also, this is the slab is 125 mm. So here, thickness forward calculation means we have to calculate the dead load of the slab. So for that purpose, the thickness is 125 and weight density of the material or weight density of the RCC is 25 Newton per meter cube, means 35 into 10 to the power minus 6 Newton per meter cube. Okay, the section of the slab has also been defined. And after that, we have to make the compound for each element for beam and Newton per meter cube. Newton per meter cube means 35 into 10 to the power minus 6 Newton per meter cube. Okay, the section of the slab has also been defined. And after that, we have to make the compound for each element for beam and column elements. So go to frame member compound. There are different options: frame member, shear wall, temple, BRB compound. So let me go to frame. I named column. So here component is column is treated as plastic section. We have already defined the component. So the proportion of honors and length is 1. And let me check yield. So here the compound has been made with the plastic column element. Okay. We check this. This is the whole column element with the elastic section. Here we can add the U zone also. We can add the U zone also. For example, U zone for a beam or column according to ACI 41.716 or SC 41. So for simplicity now I cannot model the U zone for this structure. Similarly, for the self-weight purpose, the self-weight per unit length for each compound element has to be assigned. So for column, let me go to calculator. Side of the column is 0.50 into 0.250 into 10.5 is 3.025 kilonewton per meter or Newton per mm. 6 to 5. Okay. Then I define beam compound. beam compound. Similarly for basic component, here we can select the beam reinforced section. It's 1, click add and go to self-weight section. Image 0.43 into the 5 2.0125 kilonewton per meter or 2.2125 Newton per m. So the compound has been finished, and let me close this tab and go to element there. We have to assign the properties which we have just defined for the beam and slab. So these green element are the blue element are the beams. Go to properties tab, select all the beams, then assign component, frame member, then beam component. Let me check assign. So these beams are assigned as elastic beams, either 30 by 350. Similarly, let me go to columns. Columns has been selected. Properties assign component, frame component, column assign. If you want to show the properties of assigned member, this can be from the show properties tab. So here the component will be assigned and the properties as defined. So for the slab, assign component, slab or rail elastic section, you have to purchase the complete material being 550 for the structure. Then these are the elastic steel material for tension only, for buckling, and elastic shear material for the wall, diagonal compression material for the wall, and things are not needed. But while doing the nonlinear analysis or performance-based design, time issue analysis in performance 3D, the respective material definition has been mandatory. So without the definition of the material, for example, if we take the reference concrete, the confined and unconfined concrete and rebar material, any further works cannot be continue without the material definition. So here another one is the elastic tab. In elastic there are also different parameters. So which parameter things in force differ to be applied here, which is the slab or sail. So then let's move the slab. So let me choose elastic material for the slab or sail. Slab, the unit is mm, and so here we have to assign the stiffness parameter. So here, if we take the M20 concrete, then the M modulus of elasticity is 22361, which comes with the formula 5000 root LCK. Then Poisson 50 for concrete is 2.0. So let me check and save. After that, let me go to cross sections. Here there are different cross sections for beam, column, shear wall, and slab. So let me choose first the beam cross section. Go to new, to 350. Okay. Then our beam is rectangular in shape. The width of the beam is 30 mm and depth of the beam is 350 mm. Then if we press the calculate button, all the parameter has been calculated here, and if you the axial area, torsional inertia, shear area, and bending inertia. So for the material stiffness, we already said that modulus is 22361 for M20 concrete. Poisson's ratio for the concrete is 0.2, and this shear modulus is calculated by the formula which we have already studied in strength. Here we check 0.2 at axial area. Then I'll choose force the beam cross. After that, let me go to cross sections. Here there are different cross sections for beam, column, shear wall, and slab. So let me choose force the beam cross section. Go to new beam 240 into 350. Okay. Then our beam is rectangular in shape, but width of the beam is 30 mm and depth of the beam is 350 mm. Then if we press the calculate button, all the parameter has been calculated here, and this will the axial area, torsional inertia, shear area, and bending inertia. So for the material stiffness, we already said that modulus is 22361 for M20 concrete. Poisson's ratio for the concrete is 0.2, and this shear modulus is calculated by the formula which I have already studied in strength of material. So let me check and let me set the shear modulus is calculated here with the formula within the relation of Young modulus and shear modulus with the Poisson ratio. So here we cannot go for inelastic strength at this tab now. So the section of the beam is defined. Similarly, the column sections has also been defined. 350 into 350. Okay. Then similar like beams, 350, 350. Calculate 22361 for M20 concrete, 2.2 for concrete Poisson ratio. Then let me check. Then another one is the slab. So we define new slab 1.5. Okay. Then this material is the slab we have defined in material tab. The thickness of the slab is 1.5 mm. For membrane also, the thickness of the slab is 1.5 mm. So here, thickness forward calculation means we have
Hi, my name is Jenna Williams, and this is a tutorial for creating a Perform 2D concrete shear wall after the Thompson and Wallace wall from their 2004 paper. This tutorial was created for alcohol slows enslaving people to enforce that they stay in line with each other are going to that simple test. So let's actually go outside the screen. We'll start by adding
The reference of Menegato and Intro was verified by the board. The consideration state had we have signed 0.01% student had defining the string material was like this was F415 or 14 year dash similar to the given initial phase. Then the shape of the relationship is bilinear or trilinear. So here is the indicator which was of and let me turn to the cyclic degradation factors. The cyclic degradation factor, I took the reference from this paper of the authors following the paper of these professors. So all the energy degradation factor for y, l, and x point is same for the state for all the phases of the state of the non-linearity. And the unloading stiffness factor, I put here minus 1. For more detail, you can follow the Perform 3D user guidelines. What is the page value of -1, 0 is the same for this. Here. Then take the rest 2 times the for cross sections. So for the cross sections, let me take with the shear wall cross sections. Here we can model the shear wall as inelastic section. Now let me turn into confined concrete. There are 2 options to make the fiber and location for shear wall. The first one is the fixed size, and another one is the auto size. Let me check the fixed size for the symmetric type of wall. So here, these are the fiber coordinates for confined concrete and unconfined concrete updated from this cluster section of the shear wall. So let me turn into the structure of fiber portion. First, I go for confined concrete. The coordinate for the confined concrete still is 43. Area is 285. 6. Okay. Then another coordinate is the area 35. Now let me turn into the concrete fiber. Twisted fiber and 2 concrete fibers are assigned here for this section. The coordinate is same. Area is 85. Sorry. Area for concrete is 554. The difference the coordinates. And the thickness, I forgot to mention the thickness for the concrete is 64 mm. You draw. Here is also 64 mm. Okay. Okay. Then you go insert the data for optical here also. The rating thickness is 600 to 5. The question This is free. Okay. So here the coordinate of the centroid is 0, 0 means the holding the fiber coordinate assignment. It's okay. And you can select the area of the conflict and still the area of this confined zone or boundary zone. So let me turn into unconfined. Okay. Then the fiber is prepared for unconfined. The fiber, let me turn into the component elements. For many purpose, I think fantastic shear properties, fantastic shear is brittle and so the shear value is set the shear growth. So it's and or negative or this unit. Then for the wave zone only happens in the properties properties here and everything is same. Then after assigning the material and compound element, K to KL like zone or boundary, we will continue to click push up. Thank you so much for watching.
Halo teman-teman, pada video kali ini kita akan membuka ya langsung. Dapat misalkan Jakarta gitu. infrastruktur IO atau berada pada rentang antara yield dan IO, dan damage-nya terjadi pada bawah. Jika mengacu mendekati force displace, ini kira-kira posisi kinerja struktur yaitu pada daerah yang dibutuhkan. Sekian untuk video analitik NLTH. Terima kasih. Sampai jumpa di video-video selanjutnya.
Channel, share about function, share about nothing. So all the and all the share of here all the here all so you could choose here outside fiber. This is also about okay. So this is also about 3H position, which is okay from here. So you could now so the time choose different so alright on oh it is period. So I would like to just simply I have seen my work pursued much 50.0 according to the Excel sheet point is just the Excel sheet point here. So it's very simple and very simple. Itulah. Itu nanti
Onboarding to extended stream. So that's a summary of all of those items. And if you want to learn more about all of this work, the report is available on our Capitol Commons under this title. And also, one of the students made a very comprehensive video tutorial on how to model reinforcement policy in 3D. It's about 15 minutes.
Hi, my name is Jenna Williams, and this is a tutorial was for any background 3D basics. The weeks that we tell it created Cumbia ball application basics. Direction I'm going to and if like you can save your current structure view to make it a what will we dive in? We're just going to take a quick little look at what we'll be doing in this section. A great reference for you to look at is a paper by Lowe's et al. From 2018. They did a great job at summarizing what the Perform 3D inputs really mean and how they will affect your model. And so there's a couple different parameters that we'll be using to help define yield strength, ultimate strength, and the strains that correspond with those actions. And I've put them out in a table right here. We're going to be using a couple that are from the Lowe's et al. Recommendations in that 2018 paper, but we'll also be using some for rebar that are specific to this project and just from recommendations that I've received from industry on how to model rebar. So let's start with our concrete. So we're going to click on materials. We will go to inelastic 1D concrete material. We will click new, and we will specify it as, let's start with the unconfined. So unconfined concrete. We're going to click OK. Now let's start by inputting what those properties are. Our modulus of elasticity is 3605. Oh, and also some other things that we'll need to do. Let's make sure that we want the shape of our relationship to be trilinear. We don't need to include tension strength for this model. We don't need to include strain capacities. Our cyclic degradation, we would like it to be YULRX, and the only way we're going to get that option is by clicking yes for strength loss. And then we can add YULRX. And for this project, we don't really care about upper and lower bounds. All right, so now that we've done this, I was jumping ahead. Let's go ahead and add in all of our properties. Our modulus is 3605. Our Fy will be 2.5. Fu will be 3.33. Du will be 0.002. And dx will be 0.011. Again, the way we're calculating and choosing these values is based off of this table to the right. Next, let's go ahead and move on to our strength loss portion. For the strength loss portion, we will be choosing for DL 0.00202, DR will be 0.01, and FR over FU will be 0.001. All right, what's next? Cyclic degradation. We'll be adding those factors that are over on this table to the right. So we have 1, 0.4, 0.4, 0.1, 0.1. Great. Let's go ahead and check this relationship. We can see that Perform 3D has provided us with a graph so that we can look at what's happening. If I go back to this previous slide, you can see what all of these points really mean. So right here, we're experiencing the initial stiffness of the concrete. Next will be that hardening stiffness it goes through. And then we have strength loss that occurs. Pretty straightforward in that respect. Again, this is on the compression side, and then we see that we don't have it to make sure that you're clicking that save button. Add, call it just that. We chose trilinear capacity 605. Fu will be 4. Du will be 0.004. Dx, which if you look over at, where am I going? It's not on here, but dx is calculated in relation to where these other values are. We're going to use 0.031. On the strength loss side, our DL will be 0.00404. Looks like we forgot our cyclic degradation. Perform 3D was nice enough to remind us. we'll go ahead and put in those values like we did for the 0.1 check. So we're going to go ahead and click, all right, the current, now that we know, I'll just call it rebar since we only relationship. Again, this is from a constraint our will be recommend modify click side and that kind of since we're just modeling one wall we'd like create tab can add through second rate or be young like to except now to it check recruitments that we can create and assign them and go ahead and find our so add and we just have it distributed across in the H1 final and we're at this point draw that consider tools for the use in cases so let's just to allow it the it goes for 0 until to be Alanis percent positive there in our last neutral position we're going to I can spell cyclic gravity load plus cyclic load cases. Again, just another description. Our type of load want to include P delta FX. Our number of mode shapes will be 3. The number printed is 0. I think I mentioned this earlier, but for this analysis, end up with 16 different steps. I'll go ahead and scroll to the top and click the run this set of analysis. Go. And now it is running the case. It shouldn't take that and on this side, but looks like our structure isn't we've been working with the H1 force and we'd like more history or you can see that and it looks funny because we're not at full screen, but let's go ahead and go to full screen. Get so create good luck in your future. And our model 3D in orange compares to the experimental testing in blue.